Hello everyone. In this video, I want to introduce inheritance in Swift and go through an example of how inheritance works. So I'm going to assume that you've worked with some OOP or object-oriented programming before. So I'm going to briefly define what is inheritance and then introduce some terminology, talk about what's specific about inheritance in Swift, and then we'll go through an example. So let's start with the definition for inheritance. This is an OOP principle, or object-oriented programming principle, where you can define a hierarchical relationship amongst classes. So some terminology associated with this hierarchy would be a base class. This would be the class at the top of the hierarchy, or one that has a class below it. Base class is also known as a superclass and also known as a parent class. You'll hear those different terms used interchangeably. Then below a base class, you would have a derived class, aka subclass, aka child class. So let me define the relationship more explicitly between line 14 terms and line 15 terms. So a subclass inherits the state and behavior from a superclass. So recall when we talk about state in Swift, we're talking about properties. When we talk about behavior, we're talking about methods. Remember, the definition for a class is a collection of state and behavior that completely defines something. All right, next, let's get Swift specific. In Swift, structs do not support inheritance. In a previous video, I was introducing all three types of objects in Swift: classes, structs, and enums. Classes support inheritance, structs do not. You can also have a form of inheritance for protocols. Although structs do not support inheritance, they do support extensions, which is where you can add computed properties and methods to a type, even if you don't have the source code for that type. Also specific to Swift, in Swift, there is no universal base class, meaning there isn't some class that all classes are a subclass or inherit from. So what I'm referring to here is if you're coming from a Java background, you're used to the idea of the object class, capital O object, where all classes inherit either directly or indirectly from object. There isn't something like that in Swift. All right, now let's talk about some keywords that are new to introduce when talking about inheritance in Swift. So first, use the keyword super to refer to a member of the superclass. And when I'm talking about member, I mean anything that belongs to a class. So that could be a property, a computed property, it could be a method, it could be a static method, it could be a nested type, okay? So use super to refer to a member of the superclass. All right, next, use the keyword override to override behavior or state in a subclass. So we talked a little bit about polymorphism in a video on protocols. Polymorphism is when you have the same code at compile time, and at runtime it gives you different behavior. So with override, you can have perhaps a few objects that belong to an inheritance hierarchy, and perhaps their references are of the superclass, right? Maybe at the top of the hierarchy, whatever that class is, but at runtime, those actual objects will give you more specific behavior if they have methods that override that inherited behavior from that superclass at the top of the hierarchy. We're going to see an example of this in this video. So if you haven't heard of polymorphism before, or you haven't worked with the idea of overriding behavior before, no worries, we're going to go through an example. All right, so let's go through an example. It's time to do that now. So the example is going to be an inheritance hierarchy amongst, we'll do 4 classes. So at the top, we're going to have the employee class, and then extending down from the employee class, we will have, let's see if I can move this over a bit. Perfect. Extending down from the employee class, we're going to have a programmer class. A programmer is an employee. We're going to have an accountant class. An accountant is an employee. And we're also going to have, way over here, our last class be a lawyer. Okay, so let me write out these relationships. So programmer is an employee. Same thing with an accountant. An accountant is an employee. And one more, a lawyer is an employee. So I put ISA double quotes because ISA is commonly used to represent a relationship that is inheritance as opposed to HASA. So HASA relationship is composition where one class has another class type as one of its members. So for example, an employee has a name, which is a string, would be an example of composition between the employee type and the string type. So we don't have composition relationship in this little kind of ASCII diagram I've drawn here. Instead, what we have is inheritance because a programmer is an employee, an accountant is an employee, and a lawyer is an employee. All right, so let's get started. Let's head over to Inheritance Fund, and we're going to add a new file. We're going to start at the top of our hierarchy with employee. All right, so we've got kind of a blank slate to start with here. Let's take some notes, and then we'll write some code. So employee is the superclass for accountants, programmers, and lawyers. Refer to the little diagram that I drew in main.swift. So let's go ahead and define our employee class. And note that we have to use class because we're defining an inheritance relationship. Structs do not support inheritance. All right, so we've got employee. It's going to conform to custom string convertible so that we can print out employee objects and see them. All employees have names. All employees have salaries. And here's our description. So let's simply print out some information about the current instance of the employee. So we'll say something like my name is, we'll print out the name property value, and I make, we'll do a certain dollar amount here based on our salary. All right, let's have an initializer here that simply takes a string. So we'll initialize the name property to this string parameter value, name, and let's say that all employees have a base salary of $40,000. So perhaps some subclasses of employee, like programmer, might make more than the base salary, but it'll be in addition or on top of this base salary of $40,000. So we've got some state now that all employees have a name and a salary. Now let's say some behavior that all employees have is they can all get raises. All right, there isn't the idea of an abstract method or an abstract class in Swift like there is in, say, Java, for example. So I can put this raise function as a method in my employee class, but I can't like slap an abstract keyword on it and say, okay, all subclasses of employee have to provide an implementation of raise. So what I'm going to do is I'm just going to kind of put in a little placeholder here saying to be implemented by a subclass. It's too general for an employee to get a raise, but a more specific employee, like a programmer, for example, can get a raise, and how they get a raise is going to be specific to their type, okay? So now we've got this really general employee class. We want to create subclasses of employee that are more specific versions of employee. okay? So these subclasses are going to inherit all of this state and all of this behavior. They can use this state and behavior as is, or they can override it and provide more specific or customized implementations for their type. Okay, so now we're ready to make some employee objects. We can head over to main and we can make a few employee objects if we would like, but let's say that a general employee is too general to implement. Nobody is just an employee, right? Let's say we're working at this firm. If you work at this firm, you're either an accountant, a lawyer, or a programmer. You can't just be an employee because that's too general. You wouldn't have a purpose. So even though we can make employee objects now that we have an employee class, we're not going to because it doesn't make sense for our application. You have to be a more specific employee in order to exist or serve a purpose in this hypothetical firm. So what we're going to do is we're now going to implement a subclass of employee. Let's do programmer first because we are programmers, so we're a little biased towards programmers. All right, so here's our empty programmer.swift. Let's define our programmer class. And now we're going to put a colon after the name programmer. And this is where we can list out our superclass, so the class that we're inheriting from. And then if we're conforming to any protocols that our superclass is not, we can have a comma separated list after our superclass type name. So we're going to inherit from employee. If I had more protocols to put here, I could list them after I have my employee or my superclass. But because programmer is an employee, programmer is already conforming to the custom string convertible protocol. And for the sake of this small demo, I don't have any more protocols that I need to conform to, especially not in my subclass programmer. Perhaps if I was going to conform to more protocols, I would do it in my superclass so that all of that behavior would be inherited. Like I could put equatable here or comparable here, etc. Okay, so now we have a programmer. Programmer is an employee. That relationship is established with this statement here. Let's say something specific about programmers that no other employees have is programmers get a bus pass, and that'll be bool, true or false. Do they have a bus pass? Now that we have some programmer-specific state, we want to override our description computer property that we inherit from our employee class to provide some indication about what's the state of the current instance of programmer's bus pass. So we're going to override the description property, and we're going to return a string. But rather than reinvent the wheel and rewrite out all of that code we wrote in employee to create a string that includes the name and the salary, I'm going to take advantage of code I've already written in my superclass and simply do super.description to get the superclass's description. And then I'm going to add some more specific details to that string for my more specific type, programmer. All right. Now, because I did not provide a default value for my bus pass when I declared it, meaning I didn't initialize it, my code's not compiling because I need to provide a value for this bus pass. So let's add an initializer for programmer. So this initializer for programmer is going to accept a name and it's going to accept a bus pass. So I'm going to initialize my bus pass property first. Something that's kind of specific, I would say, to Swift is that you're going to initialize the current class's properties first. So we're going to initialize all the programmer properties first. And then after we've done that, then we will call our superclasses init. Okay? If you're coming from a Java background, this is actually the opposite from Java. In Java, if you're going to call the superclass constructor explicitly, it has to be the first executable line in your method. And even if you don't explicitly call it, it's implicitly called anyways. All right, so I'm gonna make a little note about that. Call the superclass init after, emphasis on after, you have initialized all the properties for this subclass. So I'm just going to forward up that name string because it is not the programmer's responsibility to initialize name. It is employee's responsibility to initialize name because name is a property of the employee class. So now we have all of our properties initialized, right? Name is going to be name. Salary is going to be 40,000, which is going to occur in our explicit value initializer in our superclass employee. And our bus pass will be set to bus pass, the parameter. So let's say that programmers make $20,000 more than any other employee or just the standard employee. Okay, so the base salary is 40,000, but programmers make 20,000 on top of that. So after I call super.init, the salary property for the current programmer being created, value is 40,000. Now I'm going to add on top of that 20,000. All right, we're almost done with programmer. Recall that in employee, I said that all employee subclasses should have raise as one of its methods, but that's going to be implemented specifically by the subclass because it's different from subclass to subclass. There isn't a general raise that applies to all employees. So now it's time to override that behavior. So I'm going to override the method raise. And what's specific about a raise for a programmer? Let's say they get a 3% raise. So if I multiply their salary by 1.03, they're going to get a 3% raise. All right, now we have a complete programmer class and we can make some programmers. So let's try it out. Let's head over to main.swift and let's define a function called employee tester. And in employee tester, I'm going to have an array of employees. It's initially going to be empty, but as we start to finish our subclasses, programmer, accountant, and lawyer, we'll start to create some employee objects that are more specific employees of those three different types, and we'll add those objects to our general employee array. So let's add to employees. Let's do a programmer. So this programmer's name is going to be I'm a nerd, and Ima is going to have a bus pass. Okay, let's add another one. All right, this programmer will be Spike the Bulldog, our school's mascot. And unfortunately, Spike, let's say, does not have a bus pass. He just runs everywhere. All right, so we've got two employees in our employee array, okay? So the type of the reference to these two programmer objects is employee, but those employee references refer to programmer objects. Now that we have implemented our programmer subclass, we're ready to move on and implement our other two subclasses. Those include lawyers and accountants. So let me give you a task for you to try this out. So go ahead and implement lawyer and accountant. In order to do this, I have got to give you some information about what makes a lawyer and what makes an accountant so different or special compared to the general employee or programmers or each other. So what's specific about a lawyer? Well, they have this perk of getting stock options, which is going to be an integer. Their salary also is quite high. It's going to be $30,000 on top of the base salary. And when a lawyer gets a raise, they get 10 more stock options. Now, on the other hand, our accountants, they don't fare as well. So their perk is they get a parking allowance, and this is going to be double because it will represent a monetary value like, say, $30 a month or something like this. And their salary is unfortunately just the base salary. They don't make as much as programmers and lawyers at this hypothetical firm. Lastly, what does it mean to get a raise as an accountant? Well, as an accountant, you just get a $5,000 a year raise, just $5,000 more on top of your salary every time you get a raise. So go ahead and pause the video and try implementing lawyer and accountant. You can use programmer as a template. Once you got those two implemented, come back to employee tester and add a few lawyers and accountants to our employees array. All right, hopefully that went well for you. I want to start implementing lawyer and then do accountant. So I'm going to add a new file for lawyer. I'm going to be a lazy programmer, and I'm actually just going to copy programmer and paste it into lawyer and then make it more specific for lawyers. Lawyers don't have a bus pass. Instead, they have stock options. I've got to update my description as well. I've got to update my initializer because lawyers don't have bus passes, they have stock options. All right, and we've got to update this salary here. Lawyers make $30,000 on top of the salary, the base salary. So I've got to update this to $30,000. And when they get a raise, it doesn't affect their salary. They actually get more stock options. All right, so here's our lawyer class. Now let's do our accountant class. Same thing, I'm just going to update programmer for accountant. Accountants don't have bus passes, instead they have parking allowances. Got to update my description here. Got to update my initializer. I don't have to do anything to salary after I call super.init because accountants make the base salary. So super.init is going to set salary to what I need it to be for accountant. And now lastly, down here for a raise, salary is going to be appended and overwritten with $5,000 extra. $5,000 extra. All right, now we can head back over to main.swift and we can create some lawyers and accountants. All right, let's start with our lawyers. So let's have a lawyer named Kenny Dewitt. And for his stock options, he starts with 10. Let's now append an accountant. And his name is going to be Hallelujah. And his parking allowance is going to be 17.0. All right, what I want to do now is I want to print out all of the employees in my employees array. I'm going to do this one at a time so that they show up on their own line and it's really easy to read. All right, so here's the output here. Okay, I've got 4 employees. So here's my programmer, here's my lawyer, and here's my accountant. Okay, so I want to emphasize what's going on here. I have an array of employee references, okay? I've got the same code operating on all of my employees, right? Print EMP. So what this does is this invokes the description computed property for each object. So I've got a general employee reference that at runtime resolves to a more specific subclass of employee object. So that's going to give specific behavior. And this is an example of polymorphism. When I think of polymorphism, I like to think of same code, different behavior. So I've got the same code at compile time that is going to operate on employee references. But at runtime, I'm going to get different behavior from this code depending on whether that reference points to a programmer object, a lawyer object, or an accountant object. So for example, for the first two iterations of this loop, EMP is going to refer to a programmer object. So this code is going to execute. But for the next reference in that array, EMP is going to point to a lawyer, and this is the code that's going to execute. So hopefully you can see that I've got this same code with employee references, but at runtime I get different behavior, different code executing depending on what subclass or subtype of employee EMP, a general reference, points to. Now that we can print out our employees and we've seen an example polymorphism, let's see another example by calling a method that all employees have. So inside my loop, using the general employee EMP reference, I'm going to call raise. Accountants, programmers, and lawyers, they all have a raise method because it's inherited. And then in each one of those subclasses, we overrode that inherited behavior because it really didn't do much, right? With a very specific implementation for that subtype. So now emp.raise, this same code is going to be called on each one of our employees, but at runtime we're going to get different behavior. We're going to have different raise methods execute because we overrode that inherited behavior in our more specific subtypes. All right, so after we raise all the employees, let's print them out. So I'm just going to have this nice little label that's going to separate my output. All right, so here are all of my salaries before I raise them. So 60, 60, 70, 40. And then, for example, the lawyers, they have stock options of 10. All right, after raising the employee salaries, at runtime, I'm going to get different behavior, different code that's going to execute to update the objects that EMP refers to. So you can see that the programmers, they got a raise, 3%. And then the lawyer got a raise of 10 more stock options. And then lastly, the accountant got $5,000 extra on top of their salary. That's it for our introduction to inheritance in Swift. We were able to define a base class, define 3 subclasses, and then have a general array of employee references that at runtime gave us more specific method executions depending on what objects those employee references point to. That was an example of polymorphism, which is a foundation or a pillar of object-oriented programming that is enabled by both inheritance and protocols. So if you haven't checked out my Swift video on protocols yet, I recommend you head over there so that you can see another example of polymorphism in action. Thanks for watching.